Hi, Robert Decker with RMS Fitness Equipment. I'm here with the team today, Stephen Donadio, our service manager, and Emily Vinos, our operations manager. And today we're going to discuss a speed sensor issue with our treadmills. Thanks again for joining us today. On today's episode, Emily is going to begin by turning on the treadmill. We are going to discuss the problem, and it's very common for some of our clients, is they'll begin to work out on their treadmill and then without notice, their treadmill comes to a stop. This is a loss of signal between the lower electronics and the upper electronics. And so today we're going to test to see what went wrong and how you might be able to fix your treadmill for just a little cost. So now we're going to begin the test process to determine why we lost speed signal when that treadmill began to run. And Stephen, our service manager, is going to help me with that. And I'm curious, Stephen, I noticed when Emily was using the treadmill that the belt began to move and then a speed sensor error came up. Why is that?
Well, initially when you first start the treadmill, what's happening is the circuit board down below is sending initial power voltage to the motor in a way of searching for a signal from the motor itself. So that's why you're seeing an initial movement of the belt.
So now that we have that error, the first thing to check in an error like that is what?
The first real thing to check is the speed sensor itself. That's typically where the readings are coming from and where the circuit board is actually searching for a signal.
Okay, so in a Landice, where is the speed sensor located?
In a Landice, for this particular motor, it's usually in the back side of the motor covered by this dust cover.
Okay, and the dust cover is there for what reason?
Well, the name of it itself gives you the definition. It protects it from dust clouding it and preventing that from causing potentially this error that's happening as well.
Okay, so before we test the motor, or excuse me, the speed sensor on that machine, we have this motor here. Stephen, would you be so kind to remove the dust cover so we can see what the speed sensor looks like?
Sure, no problem.
And what do you need to remove it?
With this specific motor, it's just 2 7/16 nuts that you can, with just a regular nut driver, just loosen them up one on each side. Once you have the 2 nuts taken apart, and you just pretty much pop the cap. Don't
nice
drop
catch.
it. And here you reveal the major component to what reads the speed for the treadmill.
All right, thank you for that. So let's point out some of the items that are included in the speed sensor and what they do.
So it's very basic. You have here the big dial is basically an optic sensor or an optic wheel, and it spins around the speed sensor itself, or the optic sensor. And attached to that sensor is the speed sensor wire harness, which this in turn gets plugged into the lower circuit board.
Okay, so if we could just back up for just a moment. You mentioned optic sensor, optic wheel. What do those items do while the motor is spinning?
So as it's spinning, as the motor spins itself, it's actually spinning this optic wheel, and it's spinning in between this gap that the speed sensor has. And this optic wheel itself has spaces in between, and each time the space goes through is a count for the circuit board itself.
Okay, so that count then reveals voltage, am I correct?
Yes.
And then voltage would go from that sensor to the board?
So what it is the circuit board down below is sending a constant voltage to the connection that the speed sensor connects to.
Okay.
And so essentially the way it works is these wheels, every time the gap is closed, it's closing the voltage. So you'll have 3 volts, 0 volts, 3 volts, 0 volts. And that's what the circuit board is looking for.
Okay, so for instance, if we were testing it from the machine itself, dust cap on, so let's put the dust cap on if we could. So if the dust cap was on, generally speaking, then we would only have the wire exposed, correct?
Correct.
So then it's at that point that before we actually open this, we would test the harness, correct?
That's correct.
All right, so with a basic multimeter.
Yeah, just a simple multimeter that can test DC voltage. You don't need to buy something really expensive, just a basic meter would work.
Okay, so now we have the meter set for DC voltage.
DC voltage.
All right, and so imagining that we have disconnected the wire harness from the motor controller, could you just show us how to insert, actually it would be connected to the motor controller, my mistake. Connected to the motor controller because we're trying to determine voltage that's coming from the board to the sensor.
Right.
Okay, so which wires will we test?
So you're basically looking for those 3 volts like we talked about. And on the back of the harness, Landice has fortunately big enough ports for us that you can put your meter leads on the back side while it's still plugged in. So in this instance, you can use the red wire and the white wire. And what you're looking for is essentially those 3 volts. And if you're not seeing it initially, try manually spinning the motor until you start to see voltage come. And as you're spinning it manually, you'll see 3 volts, 0 volts, 3 volts, 0 volts. And if you're seeing that change in voltage like that, that means the speed sensor is actually doing its job.
Okay, very good. So now we're going to take the opportunity to actually test it on the machine and to see exactly where the fault is when it comes to a speed sensor error. So let's take a moment, set up behind the treadmill, and come back to you and test it further while the machine is actually powered. Okay, Stephen, so now we're actually going to test at the lower board section. Now we determined at this point that the speed sensor itself, there was something loose with the wire harness. But just to be sure, I notice you have the meter connected to the board, correct?
Yes.
So you're trying to determine now that the actual lower board is actually sending a signal to the speed sensor, correct?
Right. So the important thing is make sure that the circuit board itself is actually sending voltage to the speed sensor. And it can be varying voltage, anywhere between 3 to 5 volts DC. And in this instance, it's 3 volts DC. And right where the speed sensor plugs in, where the red and the white terminals go, you put your sensor in there, and you should be getting a constant 3 volts, at least 3 to 5 volts DC.
So in the example with our treadmill today, the speed sensor signal would come up. If there was no voltage going to the speed sensor, what would be the concern?
Well, that immediately is signaling towards an issue with the circuit board itself.
Okay, got it. So now, kind of backtracking, so now we're going to start from the actual signal sending voltage from the motor controller. So we've established that. So now, why don't we disconnect our meter? Let's go ahead and connect our sensor and demonstrate to our viewers. Once we have this sensor, Stephen's going to reconnect the meter to confirm voltage is, again, going through the sensor now.
So here I'm connecting to the red wire and the white wire, which is the middle one in this instance. So here currently we are getting 0 volts. So from what it looks like, the sensor is actually closing the port for it reading voltage. But if we move the motor itself, we should see a change in voltage like you see here. 3 volts DC, I move it again, and you see how the speed fluctuates from 3 to 0, 3 to 0, 3 to 0.
Okay, so we confirm voltage, correct voltage, opening and closing. However, what if we know that signal's coming through the lower board as we tested, but let's say now we put the speed sensor on and now we test it, but there's still no voltage. What's the problem?
So what can happen is if there's no voltage, that means the speed sensor itself is permanently shut. So it's not opening and closing, revealing the voltage itself.
So in this case, we would replace the speed sensor.
Yes.
And then the flip side of that is, say we're getting 3 volts all the time. Is the scenario the same?
So if it's 3 volts all the time, that pretty much is indicating that the sensor for the speed sensor is permanently open and it's not constantly shutting shutting and closing, shutting and closing.
Gotcha, giving you the proper signal again so that the lower board, lower electronics would then communicate properly with the upper electronics. So again, just to reiterate, the purpose behind the speed sensor is to communicate properly. It is a safety feature. It is something that many manufacturers use, and so it is critical to the use of the treadmill.
It is.
Well, Stephen, thank you very much for testing that for us. And as always, we thank you for tuning in and look forward to many more of these test procedures. Hopefully you're finding them very helpful. And if you haven't already, be so kind to subscribe to our station for more helpful hints. Thank you.